Copper is a protagonist in the modern world. It is present in our cell phones, electric cars, the pipes in our homes, and the massive energy grids that power entire cities. Its versatility, high conductivity, and resistance make it one of the most essential metals for society. But have you ever stopped to think about where it actually comes from? The journey of copper is a story of engineering, geology, and chemistry. It is an epic that begins in the depths of the earth and ends in the products we use every day. Let's delve into this world to understand the industrial process that transforms mere rocks into a valuable metal. Copper is one of the best conductors of heat and electricity. It possesses exceptional resistance to corrosion. It is highly flexible and malleable, and crucially, it can be recycled infinitely. In the Earth's crust, the outermost layer, it is primarily found in sedimentary rocks. Its extraction is a complex process involving several stages. The first step is identifying areas with potential copper ore deposits. This requires geological studies, analysis of samples, and exploration techniques to locate spots where copper is present in economically viable quantities. Once a copper mine is located, preparations begin for the extraction. But before reaching the valuable ore, vast layers of sterile, waste material must be removed. In some areas, the mineral deposit lies 100 meters deep, necessitating the use of heavy machinery and tons of explosives. To extract the copper-bearing rock, a large drilling machine is used to create approximately 130 holes, known as blasting holes, each at least 16 meters deep, equivalent to the height of a 5-story building. Into each hole, a powerful mixture of ammonium nitrate and fuel is added, along with a specified amount of a self-explosive known as ANFO. The hole is then filled with sterile material. From a safe distance, an operator activates the charges, causing a rapid sequence of explosions. Each blast is powerful enough to shatter an entire building. The time between one explosion and the next is approximately 2 milliseconds. This blasting technique is designed to fragment the maximum amount of copper-containing rock. Thanks to technology and designed blasting methods, the explosive energy precisely fragments the underground rock while minimizing the spread of material and dust. After the blast, the loading of the ore begins. Giant machines use their large shovels to lift the material and deposit it into enormous mining trucks. To get just 1 ton of copper, approximately 200 tons of ore are extracted. Excavators collect about 80 tons of rock at a time. This rock typically contains less than 5% copper. The trucks stand nearly 7 meters tall and have the capacity to carry up to 400 tons. Given the immense size of an open-pit mine, its operation is managed from a control center, much like the towers at airports. From there, everything happening on the site can be monitored. But how does a chunk of ore become one of the most widely used metals in the world? Various techniques are required to separate copper from the ore, depending on whether the ore is an oxide or a sulfide. For processing oxide ore, the rocks are stacked in special leaching areas. The material is deposited at the edge of the mine to begin the leaching process. There, it is saturated with a diluted sulfuric acid solution. For weeks, this acid slowly seeps through the rock, dissolving the copper. The solution containing the copper ions is collected in tanks and piped to the processing plant. In a special channel, the copper solution mixes with an organic reagent and floats on the surface. Then an acid solution is added to increase the concentration of the copper and make it electrically conductive. The solution is transferred to a series of tanks with thin copper plates called cathodes. An electric current is applied, and the copper ions begin to accumulate on the plates. In just 10 days, each plate reaches a thickness of 2.5 centimeters. The purity, or pureza, achieved is almost 100%. This is essential if the copper is to be used for electrical products. The extraction of copper from sulfide rock is a more complex process. It begins in a gigantic drum known as a mill. Inside, steel spheres grind the damp rocks into small pieces. Upon exiting the mill, the material passes over a perforated conveyor belt that separates the smaller pieces. The larger stones are returned to the mill for further grinding. Once ground, chemicals are added to coat the copper particles, and it is mixed with a foaming substance. This mixture enters flotation tanks, where bubbles lift the particles to the surface. This copper-rich foam is collected and filtered, resulting in a concentrate that is at least 30% pure. The next stage takes place in the foundry. The concentrate travels by train to large yards. There, it is mixed in layers with silica sand, known as flux. This sand helps remove impurities during the smelting process. At extremely high temperatures, the mixture turns into an incandescent liquid. Impurities made up of iron and other minerals, slag, float on the surface while the copper sinks. At this stage, the copper reaches 60% purity. It is then transferred to a second furnace, where the copper content is raised to 98%. The molten residues are poured on a pile. It is a stream of bright slag, flowing like molten lava. When it cools, it solidifies and becomes part of the landscape. Meanwhile, a crane takes the liquid copper to another furnace for final refining. The purity increases to 99%, and the molten copper is poured into molds to form large rectangular plates called anodes. These plates are cooled with a jet of water and solidify. A hydraulic cylinder ejects them from the mold, and an automated system transports them to a washing station. There, residues of the mold release agent are removed. They are then sent to a refinery hundreds of kilometers away. Maximum purity is achieved at the refinery. The anodes are submerged in electrolyte tanks and placed opposite thin metal blades called cathodes. An electric current is applied, and the pure copper moves from the anodes to the cathodes. Impurities fall to the bottom of the tank. The result is copper that is nearly 100% pure, perfect for manufacturing the most demanding cables. This molten copper is introduced into a vertical furnace. The copper melts and flows downward. From there, it is channeled into a mold that forms rectangular blocks approximately 6 meters long. The molten copper passes through an opening in the mold and is cooled with water, creating a continuous rectangular bar. Rollers significantly reduce its diameter. As it passes through these channels, the bar transforms into a copper rod about 7 millimeters thick. The copper rod exits the system, and a machine coils it in a spiral shape. Then, a machine compresses the copper roll to take up less space during transport. This coiled roll of pure copper will be transformed into the conductor wire, ready to deliver electricity around the world. This was today's video. Don't forget to like and subscribe to the channel. Goodbye until the next informative video.